Okay, we've taken a break in the notes to do this sampling distribution activity. So we're going to create the sampling distribution and then explore the relationship between the mean of the sampling distribution and the population mean of the underlying population. And then explore the relationship between the standard deviation of the sampling distribution, otherwise known as the standard error of the mean, and the standard deviation of our underlying population. So let's answer the following questions about this problem. The assets in billions of dollars of the 4 wealthiest people in the US as of October 2020 are 179, 111, 85, and 74. Assume that samples of size 2 are randomly selected with replacement from this population of 4 values. Construct the sample space when choosing 2 people at random from the list and compute the mean of each sample. So I am going to start you off here. Remember, this is with replacement, and it's good to do this a little bit systematically so you don't miss one. So we could pick the 179 person first, and we could pick that person second since it's with replacement. That means when we pick someone out, before we pick the next person, we put that first person back in the pile. So we could have 179 for the first and 111 for the second. We could have 179.85, and we could have 179.84. That's, 74. That is all of the possibilities if we pick 179 as the first person. Now we could go on to doing what happens if we pick 111 first. Well, we could pick 179 second. We could pick 111 again because of being with replacement. We could pick 85 second, or we could pick 74 second. Now, how do we find the means? Remember, the easy way to find the mean is to add the two numbers and divide by 2. So we can do all of that on our calculator if we pull it up. And let me move it over here. We have, I'll start at the bottom and work my way up. We have 111 plus 74. Make sure you hit enter because we want to divide that total by 2, the number of values we added together. So that gives us 92.5. Okay, if you want to do it all at once instead of having to do the addition and hit enter, you can, but you must put the addition part in parentheses. So that would be open parentheses, 111 plus 85, close the parentheses, and then divide by 2. And that gives us 98. Okay, I'm not going to show you all the rest in the calculator, but still going from bottom to top, we have 111, 145, 126.5, 132, 145, and 179. Now, you should try and construct the other half of the sample space yourself. I will give you a hint again. You need all the possibilities if the 85 billion person is chosen first, and you need all the possibilities if the 74 billion person is chosen first. So pause the video and try to fill that in and then start it back up and see if you got it right. Okay, so for all the 85s, we could have 179, 111, 85, or 74. And for 74, it's being chosen first. We have the same possibilities for the person being chosen second. Then we add the two values and divide the result by 2, which gives us a mean of 132, working from top to bottom this time. 98, 85, 79.5, 126.5, 92.5, 79.5, and 74. So now we have the complete sample space and all the possible means we could get. So we're going to construct the probability distribution of the sample means. And the sample means are the mean columns that we just created. So let's write down all the means, and I'm going to do them in descending order. So 179, 145, 132, 126.5, 111, 98, 92.5, 85, 79.5, and oh dear, it looks like I didn't make enough space in this table. Oops, I did. It just carried down to the next page. So let's exit out here and put it up top where we really need it. And 74 for our last one. Sorry about that. Sometimes the formatting goes a little bit wonky when we convert it into a PDF file. Now, how do we find the probabilities? Well, let's go back up here. How many means do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So our n here is 16. Oh, we shouldn't say that. We have 16 total means. The probability is the number of times that mean appears in our question number 1 divided by 16. So 179 only occurs once, so its probability is 1 over 16, or 0.0625. And you can just do that in the calculator. 145 occurs twice, so it's 2 over 16, which is 0.125. 132 appears twice. 126.5 occurs twice. So those are also both 0.125. 111 occurs once. So that's 0.0625. 98 occurs twice. So that's 0.125. 92.5 occurs twice. 85 occurs once. 79.5 occurs twice. And 74 occurs once. So Here is our sampling distribution of the mean. So this is the sampling distribution of the mean. Now, we'll finish page 2 of this activity in the next video.